So now we're going to talk about how to solve a system of linear equations. So we are given two lines. They are graphed right here, but ignore the graph right here. Well, on the graph, we can see that there is a solution, right? There is a point where those two lines intersect. We're going to talk about how to find that point if we didn't have the graph. Generally speaking, there's two methods that you can use to algebraically solve a system of linear equations. One method is substitution. Another method is typically called elimination, but in this textbook, they call it the addition method, but it's the exact same thing. So if you've heard of elimination, it's the exact same thing as the addition method. We're going to start off solving this example using the substitution method, and we'll see different examples of both ways. Generally speaking, I won't tell you to use one way well, no, sometimes I will. Sometimes I will tell you to use one way or the other, but for the most part, you'll be able to just pick whatever method you want to use. Sometimes one method is better than the other for a particular problem, and we'll talk about what characteristics of the problem make it better suited to try substitution or make it better suited to try addition or elimination. So starting off in this example here, using, I didn't have to erase that, but using substitution. So in the substitution method, the first thing you want to do is you want to isolate one variable. So you want to isolate x or y, and you can choose either equation to isolate it in. So in other words, what I'm saying is we could choose to take the first equation and solve for x, or we could take the first equation and solve for y, or we could take this equation and solve for x, or we could take the second equation and solve for y. Generally speaking, the variable that does not have a coefficient in front of it or has a coefficient of 1 or -1, that's the one that's going to be easiest to solve for. So I'm going to choose to solve for this y in the second equation because there's just a -1 in front of it. So I'm going to take that equation of 5x minus y is equal to -26, and I'm going to solve for y. I'm just going to add y to both sides of the equation. There's lots of ways you could do this. Doesn't matter how you get y by itself. So now I have 5x is equal to -26 plus y, and then I'll add the 26 over to both sides so that I have y by itself. So now I know that y is equal to 5x plus 26. Now that I have isolated one variable, we're going to go on to the next step, which is why this method is called substitution, and we are going to substitute into the other equation. So the other equation, the one that we did not use, is this one. That's the other equation. EQN stands for equation. So we know that y is equal to 5x plus 6. I'm going to substitute in for that y in the other equation. So the other equation was 2x plus 3y is equal to 10. I'm just copying it over. And now, instead of writing y, I'm going to substitute in that y is 5x plus 26. And now I have an equation that only has one variable. Right now, this equation down here only has x. So now we can solve for x in that equation. So we have 2x plus, distribute that 3, 15x plus 3 times 26 is, I want to say 78. Yes, 78. That's equal to 10. I'm going to combine the 2 and the 15 to give me a 17x. Plus 78 is equal to 10. I'm going to subtract 78 from both sides of the equation to get that 17x is equal to a -68. And then I will divide both sides of that equation by 17 to get x by itself. And 68, or -68 divided by 17 is a -4. So now I can see that x is -4. Now that we know that x is -4, I still have to figure out what y is, because remember, the solution to this system is a point. It's an ordered pair, x, y. And I can see that that is matching up with -4 right there. To get the coordinate for y, I'm going to take the value of x and I'm just going to substitute it back into what y is equal to. So y is equal to 5 times, instead of x, now I know x is -4 plus 26. That's -20 plus 26, which is a +6. So now I know that the point that this that satisfies this system of linear equations is negative 4, 6. Once you have solved for one variable, like once you had that x is negative 4, it would not have mattered which equation you substituted that back into in order to get y.